Okay, hi everyone. So welcome to our latest online meetup. So we've got a few of us here today. So we've got me. So my name's Mark. So I'm in the developer relations team at Neo. Along with me,
I'm Jesus. Yeah, I'm part of the developers relations team as well.
And elsewhere, who have we got?
And I'm Michael.
Team at Neo. Along with me, we've got Michael, and our special guest, we've got Amanda. So Amanda, I'll let you introduce yourself.
Hi, so I'm Amanda Schaffer. I'm a tech lead on an analytics team at Cisco. So science, and actually a personal project that I developed using Neo4j.
Cool, and I think you that project you've presented. I saw it on I think the slides of it. You had it a bit from you presented it before at a Pi Ladies meetup, I think. Right.
So I picked it up in Seattle a couple of weeks ago. So I was really excited to share with the Pi Ladies community there kind of some of the excitement of Neo4j. It's a cool community with lots of things. So I hadn't seen a Neo4j presentation there before and wanted to share some cool technology with them, and thought it was really good because it was a local project involving Washington hikes. So it had us there. And
Cool. Okay, so yeah, so I guess how did the talk go? How did people receive the talk when you did it in Washington?
A lot of people were pretty excited about it. I think they also kind of wanted to use it to find their hikes for it. Yeah. We're lucky there to have the Washington Trails Association been used for that, so it was a lot of fun.
Cool, and I think people who follow the Neo4j community may have also. I think you've been on Rick Van Perugen's podcast, if I'm not mistaken, quite recently.
I did a graph gist for the competition a couple of years ago, and I did some modeling with the Seattle Shakespeare Dinner. So I got an honorable mention for that competition and a really cool Neo4j water bottle. So graph databases for fun and prizes. To play, but only when they're touring, and they do other things, in the theater when they're just in Seattle. So that was a kind of interesting project to look at.
So I think Mark accidentally closed his browser window, the wrong browser window. So yeah, it's really cool. So why don't we get started with your presentation then, Amanda? Do you have it ready to show to the audience?
Sure, I can go ahead and do that.
So as you lost Mark, so we'll take it from here until he comes back. So I'm really excited to hear and see what you've built, and also because I think it's a project that everyone else could also kind of devise, right, and come up with. Because if you have the data, then it's pretty easy to get it into the graph and then start looking for interesting bits and pieces that you can find.
A really fun project. Sorry, I'm just finding my slides here. But so basically, it's a really classic recommender system project. So we got data from the Washington Trails Association hikes model, finder page. I created a data model and then loaded the data into Neo4j, took a look at what I had, and built some things. This is the data from the WTA hiking guide. It basically had search results that you could see. The search results were probably about 3,000 hikes each year. And then they have a region and a sub-region, the distance of the hike, the elevation gain, and the highest point for elevation. And then they have a rating. So people can be 1 to 5 stars, and then they kind of average that in the data. And then these little green dots here recommend features that are in the hike. So we have wildflowers. I think this is maybe and their established campsites. So this has 7 different features. And so I wanted to find a way to kind of use the social rating for that hike. How much did people like the hikes and how these features when I was recommending a hike. So the first step was basically to get the data. Here's the URL where the data is from, basically. So I scraped all the objects. So we've got the distance, we have the features just here as a list in Python, and the link to the hikes, things like that. So it's a pretty straightforward data that on this hikes page. So the data model, and basically just modeling the data so that the hike has since the high point and the type, which some of them are round trip, which is what I wanted, and some of them are maybe backpacking or one way. So it's got the region. I didn't use the sub-region in this case because I keep my hikes broad and have as many results as I could. So adding in sub-region is something you could do to make it kind of more specific if you're interested in more local hikes, but I wanted to get as many results as I could. And then I just modeled each of the features as nodes and gave them the name and connected them to the hikes with this has feature attribute.
So, Amanda, what was your approach when you were modeling this? By the way, can you also hit the little X on the page thumbnail so we can see the slide a bit bigger, if that's possible?
Oh, sure. Let me. There you go.
Yeah, there we go. That's perfect. Yeah. So
I thought about. Oh, go ahead.
No, carry on. I'll ask my question after you.
No worries. So yeah, I just thought about kind of how I wanted to recommend the hikes the first time. Basically, what I wanted to do was say, here's a hike that I've done that I liked, and I wanted to find hikes that were similar to that because I knew this was really fun. It had features that I liked. It had maybe interesting lakes, or it had good wildflowers, and so I want to find hikes that are close to that geographically and also have some of the same features of that. So I kind of used the attributes that I wanted to
By the way, Amanda, did you also get the individual ratings for the hikes as well, or was it only the aggregate rating that you got for the hikes?
I only got the aggregate rating. I just
because you scraped it on,
yeah, I scraped the search results instead of individual hike pages. So there's a lot of interesting stuff that you could do if you get the individual hike pages. Someday I kind of want to do a natural language processing project on all of the user reviews, maybe.
That would be
so
cool.
There's lots there that you can check out. But if I could scrape the results and find out, so what's the date when people report, that it's snow-free in an average year and things like that you can
get the weather data and
lots of interesting hikes.
It says, but this is only local data for the region. Is there also something similar for the whole US, or is this?
I think we're really fortunate in Washington State that we have this really great organization. So,
so it's a local
California for probably 12 years before that, and I don't think there's anything that's really statewide in California. There might be more local things for the Forest Service, for example, has lots of hike pages, but they're not and easily scrapable maybe as the WTA data. I think we're lucky that Washington also has a really good tech community in Seattle. So there are lots of people that maybe volunteer their time and help make the WTA website even better. We just have that great combination of incredible places to hike and a lot of really, technically inclined people that contribute
lucky
to that.
You. Lucky you. Really cool.
Okay, so I guess I'll just give you back control of the slides again then, Amanda, and we can continue where we were up to. So hopefully you have that now.
Sure, okay, here we go. All right, great. So we're just getting to the point where we insert the data to Neo4j. constraints, I created the feature and region nodes separately here, just because I had such a small data set for those. There may be a dozen features and kind of created those up front instead of making them dynamically, and then created the hike nodes and relationships. And then just made the note here for large data sets to batch your inserts. This is not really a very large data set, but since I was kind of presenting to PyLadies, I wanted to make an example of how to do that in Python. And I think there was a really great webinar about using real life data sets with Neo4j and how to insert them using, I think, a Yelp that was maybe a month or two ago, and I highly recommend checking that out. It was really helpful. I used some of those techniques on this project as well. So here I'm showing the Python code. Since that was the bolt driver from Neo4j for the inserts here. So we're just creating a constraint on each of the node types that I have, and just making sure those constraints exist in the database. So showing how to use schema to view the indexes and constraints that you have in your database, which I think is a really handy feature of the browser. And the feature nodes, we just made an auto commit with an implicit transaction there, created feature nodes, and showed some examples of the outputs. So you can see that the features that came up first were dogs, wildflowers, and meadows. And I tested my my program just by running it twice and said, you know, what happens if you actually violate your constraints? You know, Python exception that pretty much tells you exactly what happens there. So you can see that there's a cipher error that says the node already exists with the label feature and the property name. If I'm parsing those exceptions intelligently, I can tell exactly what happened programmatically, which is another really great feature of the driver. It's very explicit and tells you exactly what the problem is. So region nodes, I just did an explicit transaction here where we have the transaction commit on line 75 just to demonstrate a different way to do some inserts. So again, using Python, the code is all up on Bitbucket. I think we'll probably have a link to that during the webinar, and anyone can kind of check this out and, you know, modify it for your own projects, but in just demonstrating different ways. And for the hikes, the nodes and relationships. So here I needed to unwind the hike features since I had those in a list. And so the ability of Neo4j to use the unwind element of the list so that I could make those relationships, I think was a really easy way for me to process that in Python. So that was a handy feature that I was glad to have when I was inserting the data. And so here we can see that I just created batches of 500 nodes per transaction, which again, this is a small data set and it loads in probably less than 5 seconds. So I didn't really need to do this. What you would do if you were doing a truly large data set and needed to make sure that you weren't running out of memory and didn't have problems during that insert with it taking too long. So Malacca Lake is the hike that I decided this is the hike that I want to base my recommendations on. So I wanted to take a look at what that looks like once the data is inserted into Neo4j, so, which is only about an hour and a half outside of Seattle, and really nice mountain region with lots and lots of hikes. So I thought I would get some good results there. You can see that Malacca waterfalls and lakes. They have old growth forest, ridges and passes. So really pretty views. You've got a lot of features. And this is a look at when you're looking at it in the browser. So I wanted to take a look at the data that I had and just see, so where are the most hikes per region? And so here you can see there are a lot of hikes in Washington State. So the North Cascades actually has the most, which is really cool. That's a region I haven't explored that much. And Snoqualmie region, what we're pretty much right in the middle, many hikes, 169. So a lot of hikes to explore there as well.
So these regions, are they different, like states or counties, or are they specifically hiking areas?
Yeah, they're basically geographic regions, and I think the WTA selected them specific to hikes. They're kind of both geographic features, so areas where a lot of hikes might be clustered together, and that you might kind of, all of them are within an easy drive of each other. So the Issaquah Alps, is with, a set of hikes and a specific set of mountains that you would go to. So both geographic, but they're not necessarily regions that you would find on any other map of kind of hiking specific.
Cool. And then on there, you've got I guess maybe different, a new, I suppose the count statement is the most interesting on there. It's often, I guess it's a little bit different than what you do in SQL. So I don't know if you, have you done SQL before you did Cypher, or was Cypher your first querying language? And how did you find like the difference between them, if anything?
So I'm a database developer for a lot of years, so concentrated on Microsoft SQL Server. So I'm really familiar with SQL syntax. And, that was one of the things I liked when I was first learning aggregate functions that I could really relate to what I was coding using SQL. So that was a really nice feature that, like, okay, so I could think about how I would do something, translate it to Cypher in a pretty intuitive manner. So yeah, doing those aggregations was really, really helpful, and I like that feature a lot.
Cool. Okay, that's cool.
And so the next profiling step I took, I was really interested in, so we have these features, and like, so are some features more popular than others on the hikes? And I guess I found that waterfalls were the most popular feature, not by a lot, but they kind of won. So here I used another aggregate function, and I used the average. I also used toFloat because I made a little bit of a probably modeling error or parsing error, I guess. When I parsed out all of my data, I accidentally made the rating and the distance, and basically put everything in strings instead of integers and floats and things like that. So Neo4j obviously does have the right data types to do all of those correctly, but I was under a bit of a deadline to get this project done in time for my talk, and I was writing the queries that, oops, I made all of my my data types strings instead of correctly making them ints and numerics. So on the to-do list to go back and refactor my data. In the meantime, I'm using the handy toFloat feature here to convert everything to a float so that I can take the average of those ratings. So it's nice that even when you do make a mistake, you overcome that without redoing everything. So waterfalls, very popular. I totally agree with that one. The interesting thing that I noted is that of the hikes, and I know that a lot of people in Washington like to hike with their dogs, but I think the reason that it doesn't show up on this list is just because Washington State has a lot of established wilderness, not allowed to have dogs, and so those tend to be where some of the really amazing scenery is. And so I think the correlation there is more just that there are a lot of places where dogs are restricted, and those tend to be really scenic hikes, rather than the fact that people don't like dogs. They appreciate dogs on the hiking trails in Washington. So after I took a look at the data, I went to the recommendation engine. So I started out just kind of hard coding my seed hike into the Python code so that I could work on my query. And so I basically, so I'm starting with my hike, and then it has a relationship to the feature and to the region. And you'll notice here I'm not specifying the relationship type since my graph isn't that complicated. I only have between each of the nodes, and so I don't really care what the relationship is. It's just the default relationship. I just need to know that there's a link. And the direction, give me a link. So I found the features and the region that my seed hike, Malacca Lake, is in. And I looked for all other hikes that have the those same features to collect the feature names as the feature. And this was the trickiest part of figuring out my my recommendation query for the first one. The first step, just how do I make sure? I want to know that I have at least 2 features that are in common, and what exactly is the best way to do that. And so I went through a couple of iterations of this query, just trying to figure out what's the combined with getting the details for the specific hikes. And so it took me probably, I don't know, 4 or 5 tries to finally get that right. And then I settled on the collect, which is the opposite that we saw before, or the unwind call. And so I'm gathering all of the feature names and then counting to see how many there are in common. And then just saying filter in common, and then returning the hike name and the average rating. And so this is what that looks like in the Python code.
Can we just quickly go back just one second? There's only one other keyword which I think people might be interested in, is the with keyword you've got in this. What do you, why do you have that in there? What's that being used for anybody who hasn't?
So the with keyword is just basically query sections together. So I'm doing a match up at the top and selecting the features and the regions that I care about, and then I want to carry those forward to the next part of my query. And so I'm using the to kind of narrow down the data that I'm pulling forward into that next section. And that's a really handy feature that just essentially allows you to pipe different queries together and use the results from one section in your next match or in your next select there.
Okay, so in the case of the first with, we no longer care about the specific hike. So we get rid of that and we just keep the, I guess we don't care about the relationship side, so we're just keeping the feature
right.
regions. And then on the second one, you're using it to do the filtering for 2 common features that you mentioned, right?
Exactly, yeah. And that's an interesting call. I discovered that after I made these slides, I really did actually still care about that previous hike, and I needed to revise this query. So in a later commit to the Python code, you'll see that I do have an mix that I'm recommending don't include my original seed hike, because I did find out that that was a problem with the query that I was showing in the slides, that I would occasionally get my it would get my seed hike back if I chose a highly rated seed hike. So to make a change to this code later on.
Okay, and is this the first time you've written I'd say a recommendation system? Is it the first time you've done that sort of thing, or have you had any other experience using other tools to do the same sort of thing, or is Neo the first attempt?
So the recommender system here. So for the selection query, I actually switched to using the Py2Neo library for Python instead of the Bolt, just looking to explore the different ways that you can use Python with Neo4j there. And I wanted to take a look at, the differences between the different ways with Python. And so I'd used the Py2Neo, I think last year or a while ago, before the Bolt driver was kind of introduced. And so that was one that I would read a little bit more functionality. And so I did some demonstrations of how it will actually, show your results in nodes and object relational mapper instead of just a specific list. But so here we're looking at the list of hikes with the dictionaries for the ratings and the hike names, and just kind of operated hikes for this for the region that it's in. So Alta Mountain apparently is a hike that I need to do. So I'm looking forward. And so once we get that list of hikes, I decided that maybe 10 is too many. So I just want to select one at random to say what's the hike that I should do today. Get into just pulling some of the details back from the hike, and then looking at the fact that our hike is going to be a node and it has labels and properties. And this Python code is just kind of exploring how objective, and we've got the results of that, where you can see the node properties are listed as a dictionary, and then it's coming back as a node class. So, oh, go ahead.
So it would be really cool in the future kind of to also kind of add users, so your own users to your database, right? So because then you could say, these are my hikes and these are the ones that I already did, and I don't want to have them recommended again, but I want to use them as seed hikes, for instance, or I want to, my friend really
absolutely
was amazed by this hike, and I just want to see like all the hikes in this area that my friend really liked and stuff like that. So you could do really some really cool stuff if you add like users and then also users following each other and stuff like that. So I think that would be really cool.
Yeah, there are definitely a lot of possibilities for social interaction on the recommender system, and that's what's so cool is you can simply to make that happen. And like you said, just kind of importing, these are the hikes I've done, and here's what my rating was for them, and then just having that drop down of pick the hike that you want to use as your seed hike, and like based on that, and excludes the ones that I've done before. So yeah, there's definitely a pretty easy extension that can be done there with this as a base project, and it's really fun. So definitely recommend that.
I think it would be really cool to go back to the WTA and show them this, and also ask them for like open data access to their data. Actually, that would be pretty cool. To just show them what's possible if they put it into a format where you can easily.
Definitely, I do a lot of volunteer work for WTA, and I've talked to a couple of people there. I told them I was doing this project. I was a little bit nervous because the night that I gave the talk, I went back to their website, to my my Bitbucket README, and their website was down, and I was kind of scared that suddenly everyone had gone and tried to scrape their site, and I had caused a denial of service attack. But they
but it was not the case. So good.
yeah. Fortunately, that was not caused by me, so I was very very glad.
Yeah, but making this data openly available would
I would.
For others, right?
Mm-hmm.
Really nice. Are there any other features that you could imagine besides adding users? Are there other things that you could imagine would be really cool to add to the data model in terms of things that are not on the WTA page, or things that you usually as hiker care about but they are not covered there, or things like that? Any thoughts?
One thing that I did here, kind of after the initial talk, was I added a feature to choose a hike, to make a custom hike difficulty, basically. So the site actually, since I even scraped the data and thought about this project, has added a lot more kind of interesting features and better searches. So it's a really, really well done website. But I kind of wanted to create a custom difficulty rate available to sort. So I kind of created 4 difficulty levels that I thought would range between, something that was easy, that would take me like less than 2 hours if I happened to be visiting a region, to drive out the night before, sleep overnight in the parking lot, and then just spend all day hiking. Yeah. So those are kind of the difficulty levels that I came up with. And then I basically graphed what it looked like, and added those to the database, and then just created a query that would show me 10 random hikes. So I used the APOC random items.
Thank you.
Called the difficulty level and the region that I was looking for. And so I proved I was getting different results. And so that was a really fun feature. And then, other things that I might want to do in the future are of location-based features. So with hikes, it can get a little bit tricky because a lot of the trailheads are on forest roads and things like that. So it's not just distance between trailheads isn't always super straight. So you could do with some geocoding and some geographic-based things to add that data to the Neo4j database.
Yeah, so that would be something that is also should check out Will Lyons' blog post on Neo4j spatial use, and I think he has some cool Polygon usage as well. And I think he's also coming to Seattle now and then, so you should also grab a coffee and then figure out some cool spatial usage there. That would be really cool.
Absolutely, yeah. There are a lot of great features in looking. I could incorporate that into the project. That would be really interesting. So hopefully, well, I'll be too busy hiking over the summer, I think, but next winter I can work on the project more. And when it's raining, and
did you turn it into like a website
that you actually doing hikes
actively use, Amanda?
I'm sorry.
Did you turn it in the end also into a website that you can use interactively, or did you use it as like?
I have kind of in the planning put a quick Flask interface on it to make it, kind of super straightforward. But yeah,
working with a notebook would also be cool to just play around with queries and change them and execute them interactively and stuff like that. I could imagine that would be also quite handy for trying out stuff and so on and playing around with things. And that's
definitely, yeah, that's a great idea.
Cool.
The code is available on Bitbucket, and I did publish a smaller sample set since the data is the WTA data. I didn't want to publish all of it. I can kind of go and download, I think, maybe about 150 hikes that I added to the Bitbucket and play around with those queries and things like that and check out how they work.
Cool. So let's see if there are more questions. So people had a little bit of problems following you because sometimes the connection broke up, kind of audio quality, but I think we can. Was the other talk also recorded, or was it?
Yeah, was your Pi Ladies talk recorded, Amanda? Do you know?
Sorry, now I'm getting a little bit of connection breakup. The question was about the Pi Ladies talk?
Yeah, was it? Do you know if it was recorded anywhere?
I didn't hear the question at all. So the Pi Ladies talk, very fittingly, our host Seattle, so that was a great opportunity to share about graph databases, and I have a couple of intro slides in the talk, just giving a quick intro to Neo4j and using I think giving some examples of how Facebook is a great great example of how you can have directed versus undirected relationships. Like I'm on, and then that's an undirected relationship. Basically, if I'm friends with someone, then he's also friends with me, but maybe I'm following him and he's not following me. So following on Facebook is an example of a directed relationship. Pi Ladies talk was just kind of meant to be a quick intro to Neo4j and then a demo of the project, and so that worked out pretty well, and it was a great place to have the talk since the Neo4j. That was just a really cool coincidence.
Cool. And do you know if your talk was recorded or not, the one you did at Facebook?
Oh, I don't believe that it was recorded, no.
Okay, but we can put a link for the slides from that talk into the comments of the video afterwards.
Perfect.
Cool. I don't know if anyone, did you spot any questions, Michael? We all questioned out. I think there's a more generic question or general question about using Neo for graph processing versus Giraffe, but I don't expect that's something that you did while you were doing your hike analysis.
Terribly familiar with.
Yeah, cool. Really good combination of getting data, exploratory, working with the data, finding the right model, and then starting with simple queries and then evolving into really recommendation queries. I really like your approach. It's a good exploratory approach here. Really nice. And yeah, if you find time before the summer, before you go hiking,
cool,
to put it perhaps into a notebook, I think that would be really cool for people to have an easy way of playing around with the data. And perhaps you can even put the 150 hikes or so into a Neo4j database that you can connect to from the notebook or something like that.
Yeah, that's a great idea. I will definitely check that out. I'm really excited. It's really cool to build something that you can use. And so I think, especially with Neo4j, there are so many great developer resources and examples that it's just really easy to take a look and think, okay, so this is one use case, and then as long as I get other data, I can really extend this use case very easily. And so it's really interesting and a fun way to explore data.
Cool. Well, I guess we don't have any more questions, and so unless you have anything else to add, Amanda, I guess we.
I don't. Thanks a lot for having me on the meetup today. It was a lot of fun to talk about the project more.
Yeah, it was really cool. Thanks a lot. Really interesting.
Yeah, so for those of you who are tuning in for different meetups, next week we've got a special Graph Connect preview special, which is very European time zone centric. So that's at like 3 a.m. San Francisco time, but 11 a.m. UK, 12 p.m. Central European. So if you're in Europe, we're going to be doing a quick preview with a few of the speakers, Neo folks for the conference. And then we've got to come up with another online meetup after that. So stay tuned on the meetup page, and we'll come up with that. And we'll put Amanda's link to Amanda's slides in the comments, because I think the audio was a little bit choppy. So in case you missed anything, you can catch it on the slides afterwards. Otherwise, thanks to Jesus.
Thanks to Amanda, basically.
And Michael, and especially Amanda. Thanks for joining us.
Yeah, thank you, Amanda.
Thank you.
Cool. Bye, everyone.
Bye.